Okay, gang, here's your next step. Let's try number 3. Number 3, I know that if I put 10 in for my x, my output would be 25. So before we go further, let me just let you know about what an equation of a line looks like. We discussed this very briefly, I think, during our 7th grade work. So let me go to the bottom of the page here and let you all know how this works. The standard form of the slope intercept form of a line. We're talking about slope intercept form of a line. Slope intercept. That means for any given value, when I have an equation, I have a slope. You may want to make some copies of this, okay? Okay, y equals mx plus b. This is the coefficient of x. The coefficient of x represents the slope of the line in numerical form. It's going to be some kind of a fraction or a number, this coefficient. This b can be any number. We call that the intercept. It's the y-intercept, actually. It's where it crosses the y-axis. So if I have a line that looks something like this, okay, there's my line. We have a slope. How much does it rise and how much does it run? In other words, how much does it move upwards? That's the y direction. And how much does it move from side to side? That's the x direction. Okay, you notice I drew a triangle in there. So that means, well, the triangle doesn't mean anything, but that's the way you can find your equation of a line by a slope by looking at this triangle. In this case, we have 2 to the right or left and 2 up or down. Okay, so we always say the rise over the run is the slope. Okay, that's the slope, rise over run. How much does it rise as to how much does it run? Well, it rises 2 for every 2 that it runs. This slope can be simplified as, what can it be simplified as? 1. The slope would be 1 in this case. Okay, so my equation would be y equals 1x plus b so far. What is b? B is the y-intercept. It's where it crosses the y-axis. Well, you can see for this equation, that line right there, it crosses that from the origin, 1, 2, 3. 3, the distance is 3. That point that it crosses at is 0, 3. I hope you can see that okay. And so b, we say, is 3. The y-intercept is 3 because x is 0. This would be the equation of the line by looking at the line. Okay, so knowing that and having that understanding of y equals mx plus b, m is the slope, b is the y-intercept. You may want to rewind this part here that I just explained to you a couple times. Okay, let's move up to the problem that we have posed to us here. Right now, my input is 10, my output's 25. So I'm going to say my input is 10, my output is 25. Well, let's see. I could say, what's the difference between these two? And that's 15. So I could say my y equals x plus 15. So if I put 10 in here and add 15, I get 25. Is that going to work? I don't know. Let's see. Let's try this next one. I have 0 and negative 5. So if I put 0 in here and get negative 5, I don't think that's going to hold true. But what I can tell you is that this number right here, which would be 0, that plus the negative 5, something here has to equal 25. Y equals 25 plus Let's see what I'm doing here. Y equals something x minus 5. Well, what I know is that if y equals this, if I put 10 in here, this part right here has to equal 30. Why does it have to equal 30? Because 25 minus 5 would be 20. That wouldn't work. So this has to be 30. So if I put 30 back in this original equation, y equals something times 10 minus 5 should equal 25. Well, I think that's going to be 3. 3 times 10 was this x, minus 5 would equal 25. So y equals 3 times the x, which is 10, minus 5. Kind of tricky, but this will be the equation of our line. Let's see if it works on any other points. Let's put 6 and get an out point of a 13. If I have 6, let's see, 6 goes in for x, and 13 should be the y. Y equals, if I put 3x, x this time is going to be 6, and then I'm going to subtract 5. Does that equal 13? It is. Y equals 13. We have checked. That is the equation of the line. So now I have to put these numbers in for the equation y equals 3x minus 5. When I put this x in, that gives me 3 times 15 is 45, minus 5 should be 40. When I put the number in here for y, that gives me negative 8 equals 3 times x minus 5. Okay, that's for this part right here. I'm going to add 5 to each side. 5, negative 8 plus 5. That would give me negative 3 equals 3x. To find x, I divide by 3, divide by 3. This will be negative 1. Negative 1 equals x. So for this, it should be negative 1. So let's just put in negative 1 and see. Put negative 1 in here, okay? Negative 1 times 3 is negative 3, and another negative 5 added to that, that's negative 8. Then now I go to this last one right here, negative 7. If I put negative 7 in for x, what's that going to equal? Well, negative 7 in for x. 3 times negative 7 is negative 21, and negative 5, that makes negative 26. There we go. Now I just have to graph those points. So one of my first points I'm going to graph is 0. 0, comma, negative 5. What does 0, comma, negative 5 look like? Well, that means I go in the x direction first and the y direction second. So I go 0, negative 5. 0, negative 5 looks like this. 0, I go over 0, and then down 5. 1, 2, 3, 4, 5. There we go. There is 0, comma, negative 5. And I'm labeling the point. Next, this would be too big to fit on our graph. I can't really go over 15, but here, negative 1 and negative 8. Negative 1 in my x direction, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. That might be out of your picture. There we go. Okay. And then let's try another one. Well, let's try 6, 13. 1, 2, 3, 4, 5, 6. And up 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's going to be a point right there. How about that? Maybe I'll have to change my grid. But when I have 3 points, if they all line up, which they look like they do, I can simply draw my line. There it is. Okay. Hey, here's a point that looks like a point. Let's try 2, 1. Does 2, 1 work? 2, 1. 3 times 2 plus negative 5 or minus 5. Y equals 6 minus 5. Yes. So the point 2, 1 works. Okay? There you go. So I'm hoping that this will help you a little bit try to figure out graphs of lines.